Hello everyone, welcome back to my channel. I am Ranjit J, a CSC student from Venkateshwara College of Engineering, and currently I am studying in third semester. Now in this video we are going to discuss a topic related to operating system, and the subject code is VCS 303, and the topic is multi-threaded programming in operating system. Before that, we can see what is meant by thread. A thread is a basic unit of CPU utilization. It consists of thread ID, program counter, a stack, and a set of registers, and the registers are used to store the data. For example, in a Word document, after entering the text, you will observe a green and red underlines when there are some grammatical mistakes and any other spelling mistakes. These green and red underline is done by these threads only. This thread in the background checks the spelling mistakes and the grammatical mistakes in the entire text and notify us in the form of a underline. Now let us see the introduction to multi-threaded programming. Multi-threaded programming allows concurrent execution of multiple threads within a single process. Threads share the same resource of process such as memory and files. Multi-threaded programming can increase efficiency and responsiveness in operating system because multiple threads are going to perform the same process. Now let us see the benefits of multi-threaded programming. First one, improved performance. Second one, enhanced responsiveness. Third one, simplified programming. First one, improved performance. Utilizing multiple threads can maximize CPU utilization and exploit parallelism. Second one, enhanced responsiveness. Threads allow for concurrent execution, enabling faster response times for user interactions because as if many threads working on the same process, the time taken by the process will be decreased. Third one, simplified programming. Threads can simplify complex tasks by breaking them into a smaller manageable units. These threads break the large process into a smaller parts and each thread performs each part of the process and makes the task complete. Now let us see the multi-threading models. First one, many to one model. In the many to one model, many user level threads are also mapped into a single kernel thread. Let us see the advantages and the disadvantages. Advantage. Thread management is handled by the thread library in user space, which is very efficient. Disadvantage. If a blocking system call is made by one of the threads, then the entire process blocks. That means if any one thread is blocked, the entire threads get blocked. Now let us see the second one, that is one-to-one model. The one-to-one model creates a separate kernel thread to handle each user thread. Now let us see the advantages and disadvantages. Advantages. It provides more concurrency by allowing another thread to run when a thread makes a blocking system call. Disadvantage. Creating a user thread requires creating the corresponding kernel thread. This model places a limit on the number of threads created. Now let us see the many-to-many model. The many-to-many model multiplexes any number of user threads onto a equal or smaller number of kernel threads, combining the best features of the one-to-one and many-to-one models. Let us see the advantages. Developer can create as many user threads as necessary. Blocking kernel system calls do not block the entire process. Process can be split across multiple processes. Individual process may be allocated variable number of kernel threads depending on the number of CPUs present and other factors. This method is also called as two-tier model. It is separated by operating systems such as IRIX, HPUX. Now let us see the types of threads. There are totally three types of threads. First one is user level threads, second one is kernel level threads, and the third one is hybrid threads. First one, user level threads. User level threads are managed by the user level thread library, providing flexibility but limited by the operating system scheduling. Let us see the kernel level threads. Kernel level threads managed by the operating system, allowing for better scheduling and resource management. Hybrid threads, a combination of a user level and kernel level threads providing a balance between flexibility and performance. These user level threads are present in the user mode or in the user space, and the kernel level threads are present in the kernel mode or in the kernel space as shown in the figure. And these user level threads will be under the control of the user, and the kernel level threads will be under the control of the kernel. Now let us see the thread states. Running. The thread is currently executing instructions provided by the processor. Ready. The thread is waiting to be assigned to a processor. Blocked. The thread is waiting for a particular event or resource to become available. Now let us see the thread synchronization. First one, mutex, a mutual exclusion object used to protect critical sections of code from being accessed concurrently. Semaphores, used for signaling between threads and controlling access to resources. Condition variables, used for thread synchronization and signaling between threads. Now let us see the thread communication. That means how the thread communicate with each other. First one, shared memory. Threads can communicate by sharing a common memory space with each other. Message passing. Threads can communicate by sending messages to each other either wirelessly or through wire. Synchronization primitives used to coordinate communication between threads. Now let us see the thread safety. Thread safety ensures that concurrent access to shared resources does not produce unexpected or incorrect results. Techniques for achieving thread safety include locking mechanisms, atomic operations, and data synchronization. Thorough testing and debugging are essential for identifying and resolving thread safety issues. Now let us see the what is meant by thread deadlock. Deadlock occurs when two or more threads are blocked indefinitely waiting for each other to release resources. Deadlock prevention techniques include resource ordering, avoiding circular wait, and deadlock detection algorithms. Careful design and implementation are crucial for avoiding thread deadlock scenarios. As shown in the figure, process A is holding resource A and is requesting for resource B. Now let us see the what is thread performance considerations. First one, overhead. Multi-threaded programming introduces additional overhead due to thread creation, context switching, and synchronization. Second one, load balancing. Uneven distribution of work among threads can result in poor performance, requiring load balancing strategies. That is, when the threads are loaded beyond their limit, then there will be a performance very poor. Scalability. The ability of a multi-threaded program to efficiently utilize resources as the number of thread increases. Now we have reached the end part of the video, that is conclusion. Multi-threaded programming in operating system offers numerous benefits including improved performance and responsiveness. Thread synchronization, communication, and safety are essential aspects of multi-threaded programming. Careful consideration of thread states, deadlock prevention, and performance consideration are vital for successful multi-threading program. Like this, the threads help a lot in our operating system.